Hello and welcome back to another episode of the Oxford MAT Livestream. How have you been? It's good to be back live on YouTube, coming to you from the University of Oxford. We're going to talk about some MAT questions today. It's been a while, hasn't it? How's everyone doing? Good to see people in chat. Who can I see? I can see Yanni and Anusha and Arhan. People are talking about how their summer's been because we've had a few weeks off. We had some revision sessions to look at A-level maths, a bit of time for you to think about that content and maybe try some past papers. And now the plan is that we talk about past papers. We're also joined by Beth in chat, who's moderating chat for the next few weeks. So shout out to Beth. Beth is one of our current students who was also a bit of a live stream regular back in the day. I think I'm allowed to say that. I'm embarrassing Beth, I'm sure. Right, okay. How's everyone doing? Here we go. Let's put this in there. Oscar's here as well, and Anna. And there are some questions coming in, which I should maybe do very quickly, but also I have a question for you, which is how's your day today? You can let us know on a 5-star scale. How was your day? And if you want to bias that a little bit with how was your whole summer been? Oh, I look straight away with the 5 and the 1. There we go, the extremes. Always interesting to me, the fastest voters. Let's do a few frequently asked questions that I think I might get today. Since we last met, you might have got some A-level results or AS-level results or something. Congratulations on those. I hope they went the way that you wanted them to. You might have done some GCSEs if you're, I don't know, in year 11 doing GCSEs, but also looking at entrance tests for Oxford Maths for fun. You might have done other qualifications, which case I'm sure, I hope everything went well for you. You might have also registered for the Maths admissions test, which is maybe the main reason people are here, right? Is the Maths admissions test this year? I don't know. There's a website where you can go and register for that if you haven't already. There's technically an opening date and a deadline, but my main encouragement is just go and engage with this website, please, to register for somewhere to take the Maths admissions test, because however many past papers we look at, if you aren't registered to take the test, they can't do the test. If you're having any trouble with that, in terms of booking Pearson VUE Test Centre, first line of support is to contact Pearson VUE support via that dedicated registration webpage. I'll say it at the front, there's very little I can do during the live stream to help you with test registration, and I sort of want to focus on doing past paper questions if that's all right. So if you're having trouble registering, or if you have concerns about registering, I'm going to say please contact Pearson first. If you'd like to talk to Oxford, there's also a contact route through the University of Oxford. You can get in touch with us in a variety of ways, and we can try and point you to the correct team in Oxford. But I'm going to try and avoid talking too much about the kind of admin, so that I can talk about, maths. That's kind of what I'd like to do. Can I just quickly get back to this? Yes, I can. We go. Yeah, let's see. So what have we got? Right, I've forgotten what I'm doing. This is also the thing about taking a break over the summer. I have no idea what's going on. Right, good. Opinions in chat. An anonymous person says that summer has been tiring but all right, which is a good balance. Maybe they voted 3 right there in the middle on balance. And they've reminded me that you can be anonymous in Slido chat. If you'd like to join in with this kind of voting thing, and I think we'll call it there. 4.0 is pretty good. A couple of people voting 1 star though, so I hope that doing some maths is a good thing today. If you want to join in with all of this sort of thing, that's happening at slido.com/MATLIVE. There's also a big link if you joined us from the Mat Live webpage, which is here and in the YouTube description if you're watching on YouTube. Have I forgotten any links? Probably. Beth admitted to having watched an obscene number of streams, which, there you go. Questions about 2, 3 and 4 markers. It's going to be indicated on the question whether each question is worth 2 marks or 3 marks or 4 marks. That's for the multiple choice questions. I wouldn't overthink it if I were you. The questions are worth a number of marks. If you get them right, you get the marks. If you don't, you don't get the marks. Either way, shouldn't affect too much what your plan is for the question, right? You should just do the maths. And there's a question about paper. The test centres should give you a kind of erasable, they should give you a kind of whiteboard booklet. It might not be erasable. It's a whiteboard booklet thing for you to write on in the test centre. You can't take in your own paper. They're going to give you something to write on. That's for your rough work. You don't hand in rough work, but you get something to work on for rough work in the test centre. I hope that's helpful. Yeah, multiple choices. Yeah, so Oscar's sadly not correct. All the past papers that we're going to look at are 4 marks per question. For 2024, it's 2 or 3 or 4 marks depending on the question. That's one of our slight format tweaks. Yes, any material apart from the sample test was Oxford released to help us prepare for the new format. Well, we think that actually a lot of the past paper questions are useful for this new format. To be honest, I think you're going to be okay with the format change being a change in the number of questions. I think since we're not changing the style of questions or the syllabus we're using for the questions, I'm hoping that we can talk about past paper questions, and that's what we're going to do. If we want to go back to a question, we have to restart if we have a whiteboard. I don't really understand that question, but you can on the computer you can go forwards and backwards between the questions if you want to go back. You've got it's a whiteboard kind of whiteboard booklet thing, so you've got multiple surfaces that you can write on. I don't want you to imagine one tiny whiteboard that you have to keep writing over the top of. There's something like some number of sides of surfaces of thing to write on, and a method for you to get more of them. Everyone answers every question in the MAT this year. These are good things. If you want more kind of format stuff to do with how many questions are there, how many marks are there for the questions, I think the best place to point you to is the MAT Mathematics Test page, which you can get to in the YouTube description. It's a page about the maths, or you can also get to it by typing this link, but not typing LIVE, not typing live at the end. We have lots of information even when we're not live to tell you things about formats and things. You do not lose marks for wrong answers. There are no penalties for being wrong in either multiple choice or those longer questions. Yes, the rough paper solution, if you like, is this kind of whiteboard stuff that people are writing on, which is pretty close to having rough paper. Advice for materials is in there as well. Prepare for maths. If you've already done all the past papers, but you've joined a live stream with past papers in it, then you're going to see things you've already seen. I always say that any problems that you find tricky, any maths problems that you can't do straight away, are probably good practice. And there was something in there about disabilities, which I did see. I think the best thing to do is to declare disabilities or declare special access requirements when you register the test. If it's not possible for you to do the test even with modifications, then please do get in touch. Not through the live stream, I mean sort of through Oxford if possible. Good. Can you change your booking? I think you should be able to, right? Should be able to at least contact the people who you've done the booking with. I don't know for sure how the modification process works. Good question. People are putting me on the spot. This is great fun. And you get this kind of whiteboard rough paper stuff for writing on in the test centre. You don't take your own. You get given stuff. Good. And I'm at New College. Look, Anonymous knows. There you go. I do a tiny bit of teaching at New College, but I do most of my stuff in the maths department. You can't see, I suppose, but that's where I am. I guess I'm telling you a fact. I'm in the maths department. With this lovely shiny central maths department. Right, shall I stop doing FAQ? These are good questions. These are good questions. I do like them. I think some of them are on the MAT page, and there's some things where we could go into lots and lots of detail that's not particularly helpful. Sorry, on sort of how whiteboards work or something. Right, okay, so I'm going to try and move on to some questions, I think. Somebody said you can change it, log back in. Okay, if you can log back into the thing. Goodness me, right, very exciting. Does correct answer get full marks? Well, let's talk about long questions. That's a good segue. I like that a lot. This thing in here about does the correct answer get full marks? Because the long questions are actually about something slightly different from just getting correct answers at the end. I can still see chat. It's just not on the screen because I want to put questions on the screen. Long questions on the MAT, which we've been doing for ages. We've always had some long questions where people show their reasoning. People show their reasoning for the questions. They're more about explaining what's going on or your understanding of what's happening. So it might be a question where there isn't a precise number as the answer. The whole question might be to justify something. So for example, I've got this highlighted question I liked the look of for today. This is from 2007. So for example, there's these parts in here which ask you about some expression, but also ask you to explain your answer. So those are questions where we're not just interested in you stating like a number or something. I guess this would probably be an expression in terms of K. We're also interested in your explanation. And that's still what we're doing with long questions on the mat, we've got 2 long questions at the end where people will talk about their working out. Right. Somebody's asked for a link to the Miro page, which I'm not going to do because I don't know how to protect things. If you want these questions that we're looking at, you can grab them from the MAT page. I'm not certain that anything I write is going to be that useful or interesting, so hopefully we can live with what's going on here. Okay, good. Here's a question about recursion depth. I should say, by the way, there's a kind of schedule for which past papers we're going to talk about. We're broadly speaking going to go through them more or less in order. If you want to get ahead by looking at the past paper questions, they're all on the MAT page. They're just publicly available there. There's even solutions there, which might make you think, what's the point of this live stream? The point of the live stream is I can chat to you about these questions. Yeah, and answer your questions about MAT. Sophie asks about changing things without rebooking. I think you should be able to change things without rebooking, I would hope. I haven't done it myself. Shrish asks about computer science questions, and yeah, there are no computer science only questions on the MAT anymore. We've been moving in that direction, I suppose, because anyway, never mind. Yeah, all candidates do all questions for MAT 2024. Good. Okay. I thought we would use this as a kind of way to explore functions and to just talk about how you get started with questions. Sometimes these long questions, which have separate parts, sometimes the first part of the question is designed to get you started. So for example, here we've got some crazy function defined up here, which says that f of 0 is 1. I'm reading that in a funny order, aren't I? F of 0 is 1 because if n is 0, then I'm talking about f of 0. F of 0 is 1. And then there's some more rules based on whether n is even or odd in these cases where n is larger than 0. So I suppose we could do something like f of 1 is, well, this is a case where n is greater than 0 and odd, so I should read this line down at the bottom, and n is 1, because I'm imagining putting 1 in the left-hand side. So this is the last case. 1 minus 1 is 0. Welcome to the Oxford MAT Livestream, which is 2 times f of 0. This is kind of a kind of fact that we get just by putting 1 in for the value of n. Only one of these cases applies, so I read that last bit of the case. Different cases. Okay, but I actually know the value of f of 0. F of 0 is 1, so this is 2 times 1, which is 2. And we can carry on building things up like that. I'm doing this building up kind of before I've even looked at what the question really is. The question is to look at f of 5. F5. I suppose we could build down from the number 5 to work out facts about, f5 is something like, well, that's another odd number, so this is 2 times f of 4, or we could build up. I've noticed that n over 2 and n minus 1 are both smaller numbers, so if we had some smaller cases, we could build upwards to f5. Different things to say about that, right? That if you build upwards, you might get more intuition about what's going on by filling in, what's the value of f for the first 10 numbers. That might give you a really good sense of the behaviour as you see those 10 different numbers. But if you work down by starting at, I don't know, if you want f of 10, you start at 10 and then work downwards, you might do less calculation. In fact, that's the point of the question, that we're going to do this kind of recursion depth idea, how much calculations you need to do when you work out f of 10. You might get less intuition about what's going on though. Maybe more, who knows, but working down, you might skip some numbers. So here, for example, I'm working downwards because I've started with f5, and I've expressed that as 2 times f of 4, which is then, let's keep the 2 there, but then f of 4 is an even number, so I should read this middle row, and it says that I should take f of 2 and square it, where I've put in 4 here. 4 divided by 2 is 2, so I'm squaring f of 2. And then f2, so let's keep this bit of the expression, but inside those brackets f2, that's another even number, so I should do something like f1 squared, I think. And then f1 I know is 2. So I've got to do 2 squared times 2 or something. Seems pretty sensible. Good. There was a house at the table. And 2 people want to know about what the question's going to be like this year, which I'm obviously not allowed to comment on. Okay, I'm just catching up with chat. Are we happy? Sort of. Don't know where to start. How do you digest the information to make a plan? Yeah, so I start by messing around, by trying out. Here's a new object at the top of the question. What can I say about it? Can I say anything? I started by reading this kind of like n is 0. This bit stood out to me as the kind of easiest thing to think about first. That if n is 0, I'm being told this fact. And just copying it out, even though this first line really is exactly the same information as this thing over here, just by copying it out, I've got a chance to see it again later. If later I want f of 0, like I did over here, didn't I? Want f of 0 again, I've got it somewhere. Now for me writing on the screen, I'm just scribbling all over the place. For you working at home, maybe you've got some rough paper or something to work on. Maybe you've got a different bit of paper. I think I'd just like to stress at this point that my working out is going to be really messy and ugly and all over the place, because I'm trying to show you the question and the answer all on the same screen. If you're watching this on your phone, then I have to get everything onto your phone. During an actual test, you don't have to get everything all onto your phone. That would be that. Right, okay. Formats. Streaming is hard. Right, what are we doing? We've worked out f of 5, I think. I'm not totally convinced I've got it right, but I'm getting there, I suppose. 2 squared is 4. 4 times 4 is 16. Is it 32? Seems plausible, doesn't it? That's 2 to the 5. Have I done something funny? Oh, maybe that doesn't always work. It'd be good if it was always 2 to the k, wouldn't it? It's not. It's definitely not. It is so far. Right, okay, I think I've noticed a thing, which I doubt can possibly be true, right? Twice as many extra what? That can't be right. Look, I probably wouldn't do this in an actual test, but I'm now going to mess around with it. So I'm going to ask myself questions like, what's f of 3 and what's f of 4? Because look, it's 2 to the 5. You've got to do something with that when you see it, right? So f2, we think is f2 is 2 times f. If that's even, so no, I've got to read the even line. Oh, is this what I did wrong? No, this is what I did right. F1 squared, which is something like 4, which is 2 squared. F3 is 2 times f2, which is another 2. That's consistent with it being 2 to the n, and so is that. It really is. It's 2 to the n, isn't it? What a strange question. Look back, and you do. I'm going crazy, I think. Can someone back me up? Is it 2 to the n? Yeah, it's 2 to the n. Anna agrees in chat. Thanks, Anna. Yeah, okay. That's not the question, though, is it? Because now they're going to talk about recursion depth. That's a shame. I was just feeling clever. Right, okay, let's move on. Down here somewhere. The recursion depth of fn is defined to be the number of other integers n such that the most calculatable computed value of fn, which I suppose they mean when the working downwards strategy. I might work out some other irrelevant values of f just because I got distracted and I was interested in what f of 3 was. I don't think that's what they mean. Yeah, they give me an example. For f of 4, you need f2, f1, and f0. They're including f0. So they're counting that as 3. They're explicitly skipping over the f3 case that I was so interested in up here. Okay, so I have to calculate 3 previous values. Right, for the f5 calculation I just did, we need f4, f2, f1, and I suppose I did need f0 really in order to work out f1. I worked a little bit forwards and backwards up there, so I think the depth is 4. Am I out by 1? No, I think that is how it works. Go back and check 3 because you need 1, 2, 3 things. I've been hurt before by things being the degree is 1 more than the minimum number of Always go back and check the definitions of the things that you're working on. It doesn't hurt to read it twice, does it? Right. Oh, I've become all nervous. Let's try and fix that. A sensible thing to do would be to look at the questions ahead of time. You probably did do that before the stream. I'm slightly underprepared, but relying on the fact that I've done this past paper before at some point in my life. Here we are. Maybe I'll get a chat to join in a bit more. Okay, there's parts of this question to ask about recursion depth for other numbers or expressions. Broadly speaking, we're supposed to track what happens. So, oh no, it's not asking about recursion depth, is it? There's a trick. We're going to eventually say that it's recursion depth. Kind of sort of clearly related concept, isn't it? Because look, there's all this n over 2 stuff and the n minus 1 stuff. Interesting. Each one points you to the same smaller number in each case. This is 2007 question 5 for the person in chat with the excellent username maths question mark, which I do like. Sorry, so this is just asking me to calculate g of 5, which is fine because 5 is an odd number, so I do 1 plus g of 4, which is g of 4. G of 4, 4 is an even number, so this is 1 plus g2, which is then 1 plus 1 plus g2 is 1 plus g1, and g1, well, 1 is an odd number, so this is 1 plus 1 plus 1 plus g0, and that's 1 plus 1 plus 1 plus, oh, was there an extra 1 plus in here? There was an extra 1 plus in here. 1 plus 1 plus 1 plus 0, which I believe is 4, so that does match up. If I get the right number of 1 pluses in. A clever thing to do might have been to add those together along the way as I was going. We'll get there. We'll get there, chat. Right, okay. So here we've managed to get down to a bit where there's some explaining to do, which is, I guess, what we should be talking about. We're doing calculations and talking about building intuition and discovering that maybe this is not a function we should be scared of. It's just 2 to the n, really, or 2 to the k. Let's try thinking about what would happen for this g of 2 to the k thing in here. Where n is, yeah, where n is a power of 2. I suppose what I really want to talk about is this briefly explain your answer. Maybe I'll have a go at this down here. So 2 to the k, I think I'd start by noting that this is even for, and I suppose that's not always true, is it? Because if k is 0, then this is the number 1. I don't want to fall into this trap of saying that the thing is even if it's even or the number 1. I don't want you to think that I think that 1 is even. Okay, so I've got my terms and conditions. 2 to the k is even for k larger than 0. So for k larger than 0, let's just zoom a little bit, there we go. So for k larger than 0, g of 2 to the k is 1 plus g of 2 to the k minus 1. And I might explain, I might put half a sentence here to say this is the middle case, maybe in brackets or something. This is the middle case. I don't think that's really necessary. It's pretty obvious what I'm trying to tell you. We've got an even number. Things moving around like this. I think the key idea here is going to be that, well, this also looks like an even number if k is larger than 1. So I'm going to try and summarize that as, so keep going until you reach g of 2 to the k is, now how many 1s am I going to spit out? Each time I spit out 1 plus, now I'll spit out another 1 and divide by 2, so the power will keep going down and the number at the front will keep going up until you reach, so I suppose this will keep going until we reach k 1s out the front, and we'll have subtracted k off the front here. 2 to the 0 is 1, so this is k plus g of 1, and then I have separate opinions about g of 1, I think. G of 1 is something like, well, now I'm just calculating. 1 plus g of 0, and again I might write out using this is the last case or something, and then this, and I might even write out g of 0 equals 0, just to make it really clear what I've done in between there. Looking back at it, I now realise that having got to the end and got to an answer, I should probably go and check this against things like G4. Do I know G4? Well, I sort of strongly suspect that it's recurrence depth, which is 3 for this, when you put in the number 4. I sort of strongly suspect, because I can see this part of the question down here, that is the recursion depth, and I have some data that when you put in 4, you're supposed to get a recursion depth of 3, so maybe G of 4 was supposed to be 3. That's the case k equals 2, because 2 squared is 4, which is 2 plus 1 really is 3. So that gives me confidence that maybe this lines up in the one case that I've got. I should probably check another one, but just for my own peace of mind. Here's what I was going to say. Looking back at it now, I realised that the really important bit was this idea of keep going. So looking back at it, if I have more time, I might come back and add maybe a footnote or something with a little star. Subtract 1 from the power, add 1 outside, using the middle case, k times total. I might try and add some extra kind of detail on what exactly we're doing each time round. Now that in hindsight I can realise that's the main part of the idea. Oh, middle case. Yes, I'm sorry. I should explain what I'm talking about, shouldn't I? I do mean the middle line of this kind of cases thing. Some people refer to these as different cases. If you're in the case that n is even and larger than 0, you're in the middle case, I would say. I'm trying to use middle case as a kind of quick shorthand to say this stuff in the middle. If you haven't seen this before with the big curly bracket, I think that's what it's called. For functions, people sometimes say piecewise functions, or functions that have got this kind of separate things going on. If you do any programming, you might have met a kind of cases environment, or some sort of switching behavior where your code might do different things depending on different logical tests. That's sort of what's going on here. There's some logical tests to do. The idea is that you meet at exactly one of them in any case, and then it tells you what to do in those cases. Oh look, there's me using the word cases to explain what cases are. Sorry, that's not very helpful with me, is it? Okay, I'm going to leave part 5 because I think it's actually extremely similar to part 4. The logic is very similar, right? This looks even to me, provided these things are bigger than 0. Keep going until the small one hits 0. Keep dividing by 2 until the small one hits 0. And then you'll have an odd number. So just briefly use this last case one time, and then keep subtracting. I'm not sure what you'll end up with. It's possibly L plus 2 or something, like one more than you might expect. Which makes me suspect that this is something to do with, well, never mind. Does the number k matter? No, probably not, because you just keep going until that top power. You keep dividing by 2 again and again and again. Broadly speaking, you're going to do that about L times. Right, that was a bit wishy-washy, wasn't it? Obviously, I need to say more than that and to make sure I get the actual correct expression. But there's some logic there as to, the question is more about what happens as you start trying to evaluate g of 2 to the L plus 2 to the k. Good. Yeah, okay. So I think as soon as Anna saw this, Anna in chat said, this just looks like a formula for the recursion test. And it is, right? We've got to explain briefly at the end of this question, to explain briefly what's going on. And the logic that we're using to count the value of g is something like each time if n is even and larger than 0, divide by 2, I'm going to think about that number, but also increase the count by 1. If n is odd, then we're going to look at this number and increase the count by 1. The question really is, what are we counting? And I suppose that the thing we're counting is how many times round we go until we eventually stop because we hit g of 0 equals 0. That's precisely the same operation that we're doing when we counted the recursion depth back in the previous part of the question. That for the question of recursion depth up here, it doesn't matter what we're doing to these expressions. In one case we're squaring and in one case we're multiplying by 2, but all that matters is that we're using that number. 1 down. Moses asked a good question, which I'm now going to read out. And I'll put it on the screen as well. Is GN having the same regression system with the argument set that monitors the recursion depth on each step by +1? Yes. So it has the same. I like the word system. I'll try and put more detail in if I was writing up an explain why kind of paragraph. But I like the idea. Yeah, it's the same system. It's got the same cases, and it also involves the same arguments in the function, which it's hard to say what generally we're working with here, but it's doing the same things, putting the same numbers in as the input to particular functions. So yeah, I'd say it's the same shape, the same shape as f. It's asking you to do the same, well, asking you to do things with the same inputs. Yeah, so each one down here represents a computation, represents, increase your computation count by 1 because you're being asked to go and look at another function, f, with a different input. And you should go and look at that input next because it's going to require some computation too. So you sort of get a direction to go and look at a smaller number because that's what f's doing. But you also have to add 1 for using some time. if you want f5, well, it's something to do with f4 and +1 for asking. And then now you need if you're working out f4, well, f4 is even, so it's something to do with 2 and +1 for asking about f of 4, right? And then they keep going down until eventually you hit f0. And the count along the way is how many questions you asked about f, how many numbers you put in, until eventually you were allowed to stop because you hit this thing right here. Okay. Yeah, time management question as well. Totally up to you how you manage your time. There's no rules about how long you spend on each question. You might like to base your timings on how many marks the questions are worth. You don't have to. So if you want to spend, I don't know, half your time on the first 50% of the marks, that sort of thing, then that might be a ballpark that you choose to use. But I wouldn't stress too much about if you're in the exam and you've spent the first 50% of your time on 40 or 60 marks of questions, then I wouldn't be too stressed. If you're running out of time, do have a look at the other questions. You never know. Okay, that was not helpful advice, I think, because stuff about timing is probably quite specific to you and how you find different topics and different questions. So it might be optimal for you to sort of skip things and come back to them at the end, to have maybe a look through where you answer things that you think you can do quickly for a confidence boost, come back to harder things, or I don't know, maybe you get a confidence boost from doing all the questions in order. It really is up to you. Yeah, and the test is 150 minutes and it's 100 questions, not 100 questions, that'd be ridiculous. 150 minutes? 2.5. Yeah, 150. Sophie's right. 150 minutes. No, Sophie's wrong because it's multiple marks per question. That's 1.5 minutes per mark, Sophie. You see, you confused me. Right. Do people complete the paper? No, most people don't score 100, right? And I sort of think that if everyone had twice as much time, everyone would score a few more marks. We have to stop at some point. And this will sound really mean, but it's it's not a useful test if everyone gets about 90 to 100. Right, okay. Yeah, sorry, Sophie. Okay, right. Okay, Anna briefly believes, like me, that there might be 100 questions. I was very scared. Right, okay. What should we do next? I think I've exhausted useful things to say about this question. If you want the details of a specific part of this question, then I suppose I'm going to point you to the MAT website to look at the solution on the website. If I said something weird about how I would approach this and you want to talk about it, do put that in here. If you want the format of the MAT, then please do check the MAT website as well. There's a link in the YouTube description to the MAT page, and you can also get there by, well, I would hope by searching for MAT submissions test or going to the departmental website and following the links for the mathematics submissions test. However you found this should point you towards the math submissions test, I would hope. That's a request for a question. That's nice, I like that sort of thing. Yeah, there are slightly different types of tests. Good, okay, right. Let us, I'll take that request, I think. I don't know if I'm going to do every request that comes into chat. I've highlighted some that I wanted to talk about. Let's see if they line up. No, not really. Oh, you want to talk about the robot question? I want to talk about the robot question. That's a good sort of logical reasoning question. I like the robot question. So we're jumping to 2009 question 5 because there was a request in chat and because I like the robot question. This is a question about drawing a line through a grid of squares so that you never go diagonally, you go horizontally or vertically. When you have to go through all of the squares and get back to where you started. So here is an example of doing that on a 6x6 grid. So you see that kind of line there? It looks a bit like this. Goes around it goes through the middle of each square. And what else does it do? Yes, it goes through the middle of each square and it gets back to where it started. Good, okay. People in chat are happy about this. They generally seem to, so far, people are saying they liked this. Good, okay. Right, so this one is from, well, 2009, isn't it? So I now realise, probably sounds like quite a long time ago for people watching the stream, but for me, 2009 is not that long ago. Here we are. So, the question wants us to try drawing these things, which I could have a go at on the board, but I think it's probably more fun for you to have a go yourself. You might find that it depends whether n is even or odd, what your strategy is. And then, like me, you might reread the question and discover that n is even. Okay. Good, I was worried about that because of, well, 3x3 being impossible. So stupid. So I missed the word even, and I was thinking, I have no idea how to do this because how am I going to get through all of these squares? I can't go through the middle one while also getting back to where I started. That's a problem. Oh, is this part 5? This is part 5. Interesting. Okay. Right. I noticed that's not just me skimming the whole question. I noticed up here it said 4. So I thought, ooh, what's 5? Why doesn't that say all parts of the question? Anyway, structure. Okay, not possible if n is odd, apparently, but we're going to start by thinking about n being even. In that case, I think I want to do something like this. I don't know if I'd do this wobbly hook-shaped bit. I think we'll just go up and down. That works, doesn't it? Half the columns are kind of down, half of them are up. You could do this tooth shape at the bottom, but I don't think you need to. Just sort of go up and down the rows, but make sure you leave yourself one row at the bottom to get back to where you started. Sounds doable to me. There's probably somebody in chat who will tell me that they did this by mathematical induction, in which case, well done you. I will draw a wobbly diagram. Yes, or yeah, so Kuba says they've doing a small diagram, then a slightly larger diagram, and spotting the pattern, which is basically mathematical induction, isn't it? And it's funny to me slightly that the person who requested this question has also interrupted this question to ask about GCSEs. So I guess I'm going to say that Oxford's got no minimum GCSE requirements. Obviously prefer it if exams went well for you, but GCSE exams are quite a long time before university, and some people do a lot better when they're allowed to focus on fewer things at A-level and then fewer things at university. So if you've got a mix of GCSE grades, then perhaps that's helpful to you choosing what to study at A-level, and I hope maths is one of the things that you've chosen to study at A-level. No, it's okay, don't apologise. I just find it amusing. I'm doing the thing you wanted. Right, okay. Somebody in chat, tell me about part 2. This says, is a tour still possible if the start finish point is, instead of the top left corner, different square? And crucially, I would like you to justify your answer. So there's probably someone very quick in chat who tells me like yes or no, with like a reason. And for the person who asked about answers or explanations, I'm not sure how many marks you would get for saying no, or how many marks you would get for saying yes. Actually, one of those is worth 0 marks because it's wrong. Yeah, so someone chats very fast and said, yes, it's possible, even if you start in a different square. Let's get some justifications. I just got a little note. Oh, there we go. All of the stuff around the edge of my whiteboard decided that this was the perfect moment to install an update. I suppose it was. I was asking you a question instead of writing. Yeah, okay. Let's go with this. Every square gets passed through once, so you can start wherever you like. Complete circuit, so any square. Yeah, okay. Anonymous says, is a complete circuit, so any square works. To embellish on that slightly, you mean the solution that we found in the previous part was a complete circuit that went through every square. So you're allowed to refer back to what you previously did in previous parts of the question, and I think that's what you're doing, to refer back to, I just convinced you with the diagram, right? I just convinced you in part 1 that you can visit every square. So if you have a special square you'd like me to start, well, that's fine. I did visit it in part 1. I'll just change the bit on the, if you like, this is a silly thing to say, but change the bit on my circuit where the blob is to be in a different square. And now you have a picture where the blob is in your chosen square, but it's still a circuit. We're using the word circuit there, which maybe not everyone would use. You don't have to use, I'm going to say, technical words or invented words or things like that. You can describe the situation. Sometimes it's handy to make up a word like circuit for something like this. I suppose the question's already done that for us, right? The question's already invented the word tour. They've defined it at the top somewhere. Yeah, tour in italics is a path drawn, blah, 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 blah. So maybe we should use their word. But probably they'll know what we mean if we say circuit or grand tour or something. Oh, they already said tour. Okay, good. Yes. And then Anonymous is talking about for every up movement there needs to be an equal down movement, and same for left or right, which I think might be spoilers for part 5. So I'll come back to you in a second. Not spoilers, right? You're just answering the question, probably. Yes. Oh, Arhan's got a slightly different approach in chat. Let's put it on the screen, which is to describe how you would do it, starting from any square. Unequal spacing of the edges. That doesn't make me think a bit, actually. Unequal spacing of the edges, what do you mean by that? Probably there's more space on one side than the other because n is even, so the remaining space, not counting the column that you start in or something. Or maybe row is odd, so unequal. So there's space for that return path. Having done, I guess you're imagining the wiggly up and down stuff to be in the opposite direction to the orientation of your return path. Cool, yes. Right, okay. Are we happy? You can probably do the starting anywhere. Lots of different reasons are available. Any reason that is reasonable should be given a reasonable number of marks, I think. Which is sometimes hard to see on the web solution that we put on the map page. Sometimes it's just one solution, or sometimes there's a couple, and they might not match your solution, but you know, be confident if your solution makes sense. Is logical, then it might also be worth marks. There's no reason to think it isn't if it's, it's true and correct. Good. Okay. list of commands. What are we doing? Oh, we're going to explain why the amount of spinning is a multiple of 4. Oh, plus 1. Oh, because it doesn't turn at the end or something. Right, so it's clearly a multiple of 4 being like how many times it spins or something. So I see multiple of 4. That's a stupid way of reading the question, right? But you read this, I don't really know what's going on. It says multiple of 4, and the turns were right angles. So that's a quarter of a full turn. Multiples of 4 makes me think all the way round. And all the way round is what you might say for a tour, that you go all the way round and end up back where you started, except you don't quite end up back where you started. If you start in the top left, then you started, oh gosh, where did you start? Oh my goodness. You started facing in some direction. The first command is an F, so you started facing in, oh, initially it's up here. They tell us so much stuff that I should read, shouldn't I? And I'm going to have to remember which way clocks go. Disaster. Pointing to the right, and the first move is F, so I guess describing this sort of thing, going over here, and then moving onwards. So it'll end up going up like this, into this square. Could we do some spinning at the end? Could it do some spinning at the end? I've confused myself. I might need chat to help. Maybe it can't do some spinning at the end. Feels like it could do a celebratory spin round at the end, messing up the value of R, but I think I'm missing something. Good, okay. I know what they're trying to do. You want me to say that it started facing right and it's going to end up moving upwards. So 1 extra turn would bring it around to a multiple of 4. Spin, 2 wrongs don't make a right, but 3 rights make a left. Yeah. Maybe you're telling me that the rights and lefts. It's strange, isn't it? The rights and lefts don't quite balance out. You can see this on, I guess, what do I mean by left? You have to spin, oh yeah, so that's 3 rights to turn left. You see this on Formula 1 tracks, if you count how many left turns and right turns there are. It's very unusual for it to balance out and be the same number of right turns and left turns. That's probably not true. Because in this problem, the corners are fixed to being 90 degrees, and in the real world, turns don't have to be 90 degrees. So you could have like one really big left-hand turn followed by a wiggly section, and then hiding in the wiggly section, 4 or 5 small right-hand turns. What am I doing? I don't know. I think we're explaining things like multiples of 4 and spinning and how you might get intuition for how to start with a question and what sort of nonsense you might start scribbling or thinking to yourself. As for example, this part 3, where it feels to me like this might be no, because we've made so much of a big deal about how you left this square in one direction, you've entered it from a different direction, and they said top left. Yeah, maybe if it started a route, still hold. Well, I think maybe the answer is like maybe the number of r plus 1 might be a multiple of 4, depending on what the root is. Because I think it's the root that matters for this argument, not the fact that, not the fact that it's top left, because we would still be drawing these little arrows and talking about how it started facing right and ended up pointing up. We would still be having that conversation if the root went like around here, and it wasn't top left. The fact is just that the root does that. It has to do that for the top left, but the result would also be true if you started like over here instead, facing to the right and ending up facing upwards. That would still be fine as well. So yeah, I think it depends on the root. So I think I'll try and include that in my reasoning or my explanation. To say it doesn't must is too strong, but maybe it's true. I think. can probably design a particular route where you don't start right in the middle, but you do have r plus 1 being a multiple of 4. And I think I know what the value of f has to be, because that's how many times it executes this function to move to a new square. We're counting function applications again, just like in 2007, to count how many times it has to move to a new square. Still think we're assuming that there's no sort of pointless spinning at the beginning or the end. I think I prefer this if it started and this is now question designing. I think I prefer this if it initially and finally or something. If it also ended facing to the right, you know, it had to get back to its starting position, and then it would be the case that r is a multiple of 4. And I think you could argue then the next part would be a little bit easier as well. I don't know. Maybe that's how I would write the question. To also talk about how it finishes. Okay. And then last part, sometimes the last part of the question is just sort of added on. Sometimes it's testing your understanding of everything that's been going on, and sometimes it's just covering a slightly different case, which might be easier or unrelated. So in this case, there's this thing not being possible. So instead of counting or arguing about possibilities, this last part of the question is just to say something about n being odd. Yeah, I think we should assume that it finishes when it gets to the box at the end. Yeah. There's a request for more question 5s. We'll look at more question 5s. I would like to do a truth or lie question, because I think they're neat. So I think we'll do a truth or lie question at some point as well. Let's have a quick look at chat. Yeah, f depends on the dimensions of the grid. Maybe there's a nice function relating n to f. That's a good intuition. I like that. You're correct. There's a nice relationship between, if you like, the size of the grid and how many times the poor little robot has to execute the command f, which moves it forward 1 square. Poor little robot. If n is large, it's got a lot of grid to explore. You've drawn a wiggly path in part 1, and poor little robot is going to execute command F to get to the next square every single time. Right. Yeah, and if you would like the solution, you can either check the MAT Live website, or you can now check chat, where people are now telling me a relationship between how many times this poor little robot can take a step forwards and how large the grid is in some sense. Okay, quick pause. I like these questions. We should maybe look at some multiple choice questions, but let's mix it up. Maybe after 6 o'clock we might look at a multiple choice question or something. There's a request in there for moving on a little bit. 2008 question 5 is a bit of a classic. I wasn't really planning to talk about it too much. I suppose it does have explain your reasoning in every part of the question, so that's a nice feature. This is a good example of a question that gets you to explain your reasoning. It's a little bit of a classic. I think for a long time we've had it on the right at the end of the prospectus. So if you come to an open day and get a link to the digital prospectus, or years ago if you got given a paper prospectus, back when we cut down trees and made loads of paper prospectuses. This is one of the questions that we gave you as an example of a MAT question. That's what I mean by classic. It's a good question. It's got various things going on. Crucially, the missing word, if you like, or the thing that really helps you unlock the problem, pun intended, is to think about factors. I don't really know how you have that idea other than, well, the question goes to this great effort to talk about 3, 6, 9 and so on. The good thing there to think is multiples of 3. It's just a maths concept that you're aware of that you can maybe use. The question is then talking about specific lockers. So the question is something like, is this a multiple of 1? Is this a multiple of 2? Is this a multiple of 3? Which, said differently, if you're looking at a particular locker, you're thinking about the factors of that number. Right. There's also a lot of counting going on. A lot of, the first student does a thing, the second student does a slightly different thing, the third student does another thing. In here, part 3 is maybe the most classic of a classic question, which is to ask what happens after all of the students have passed. The question's got 4 variants of this, I suppose, to think about 300, 400 or 1,000 students walking past and ask you about particular lockers or the count of lockers. I suppose the crucial thing here is to think about which students change the state. You see, that's a subtly different question, right? The question, I suppose, is what's the state? Like the literal question printed on the page is what's the state of locker 100? That's impossible unless you engage with the idea that the state changes when students open or close the locker. So then you realise that maybe they're just opening and closing it. You care about how many students open and close the locker. That's maybe your kind of first step in exploring the questions of what's the state of is something to do with how many, or maybe more precisely, is the number there even or odd? And a subtly different question, if you want to analyse, a big collection of things, if you've got an odd number of things or an even number of things, a good question is what are the things, or in this case, which students are in this kind of set of people who have interacted with locker 100. It's the factors of 100. And then you're thinking about factors of 100. And you know about the number 100. You can probably work out its factors, I think, pretty straightforwardly because it doesn't have too many of them, does it? It's 2 squared times 5 squared. So it's got 9 factors. That's not that bad. Thank you, Sophie, for answering questions that I've missed in chat. You're doing my job for me, but thank you. Yeah, okay. Good. Okay, someone requested this question. I'm going to say, think about factors. Parts 1 and 2 are very, very careful counting to track what those first few students are doing. I guess the clue there is that things tend to repeat because the behaviour of each student is very repetitive. Anonymous in chat says that the students have a very sad life and because their behaviour is so repetitive. So probably their effect on the lockers is also repetitive in some sense. So if you have to, you could draw out what's going on with the lockers, and you should find that's quite repetitive. Probably after, I don't know, about 12 lockers or something, you've got the picture of what's going on. And scaling up from 12 to 1,000 shouldn't be too hard. Gosh, thinking carefully because 1,000 is not a multiple of 12. That's student 3. This is a fiddly counting question, but we'll be very careful. That's how we get all the marks, is by being very careful. I suppose using my method of kind of changing the question, playing around with the question, this last part here, what's the state of locker 1,000, is something like how many people have interacted with locker 1,000 at this point in time, context of the question, after this thing's happened. How many people have interacted with locker 1,000? Is it even or odd? That means something like which factors of 1,000 have we had so far? So that's a question like how many factors does 1,000 have that are less than 100 or including 100 because it's after the 100th student? Oh, out by 1. Good, right, yes. Yeah. So the bit part 3 is vaguely well known. I say well known. All things are relative, right? But I feel like I've seen part 3 somewhere else. I think it still works because parts 1 and 2 and 4 are a little bit different. You still have to do this careful counting in parts 1 and 2, and then part 4 is a bit of a twist where we're midway through the process. So if you've seen this logic puzzle or something somewhere, then you still have some things to do. Good. Okay. There's a question in chat about people getting very high math scores but not getting into Oxford, and that's because we have other bits of the application as well. I'm doing a whole live stream talking about maths, but I'm not doing live streams talking about your predicted grades on A level, your UCAS reference, your other mathematical activities that you get up to, your interviews. Well, we are doing live stream about interviews. We've got a bonus live stream at some point in, oh gosh, maybe November or December or something. I'm talking about interview questions, but there's other things going on in the admissions process. It's not just on maths scores. Someone else had this on their wall. They have all of it on the wall, including the 100th and the 1000th. That kind of Oxford MAT innovation of asking about what's going on after 100 students. Oh, terrible. Okay, so sort of, yeah, okay. Thanks for requesting this question. I would like to talk about truth lie question, just for fun. So I know what you're going to ask. I know what you're going to ask. I'll put the chat on screen as well. I know what you're going to ask. This is question 6. Matt no longer has question. Anyway, never mind. Matt no longer has a question that is only for these people this year. All the Matt questions are for everyone. I didn't want to talk about it because I've always thought that maths candidates should be able to read and understand the computer science questions and maybe even find them interesting, and vice versa a bit as well. So here we are. Here's an innovation on truth lie. A liar, a saint, and a switcher. The switcher sometimes tells the truth, sometimes lies, which you might have met before as some sort of random person who you can't trust either way, to either be reliably wrong or reliably truthful. Here are their statements. Person A says, I am the liar. Person B says, A is the liar. And C says, I am not the liar. The question just wants us to decide who is the liar. Which, they seem to agree about it, so that's nice. Maybe we should just pick A, because that's what they're all saying, isn't it? Let's think it through. There's some cases to think about here, right? Different possibilities of what might be going on. I personally prefer it when they give them names for A, B, and C, but I suppose this question has to get through quite a lot of different cases, including some different roles, like the contrarian. The contrarian, we're jumping ahead a little bit, the contrarian depends on what the previous person did, which is a bit different. There was a suggestion in chat. Yeah, look at the cases. Assign truth. So there's kind of 3 possibilities, right? We're told one of these people is a liar. That seems confusing. Another is the saint. So maybe a saint. And I might scribble something like this later when I come to briefly explain my answer, or I would turn that into a sentence or something. No, because of A's statement. So it kind of fails at the first hurdle, but if A's the saint, well then they wouldn't go around saying that they were a liar. In fact, also, if A is a liar, then this is also impossible, because liars don't say that they're liars, they would lie about it. That's the joy of being a liar, that you don't have to tell people the truth about your own nature. I said that like it was really coming from the heart, right? Okay, let's move on quickly. Okay, right, I think A is switcher. Okay, so I'm ignoring them. We've decided that A statement is, well, not useless, but I'm not going to read too much into it. Right, so what have I got then? I've got B and C. B says A is the liar. B is then lying. I'm kind of reading down the page, right? So B's lying. Interesting. So he's got kind of case-based approach, by the way. Thought about the possibilities of what's going on. I think we now know they're not the switcher because we've assigned switcher to A. I think this, it seems harsh, but I think this one lie reveals B to be a serial liar who, quote, always tells lies. Which I think leaves us C telling the truth. This would be a truthful statement. That's all fine. I think I can stop thinking around here though, because I'm just started to do the liar. People in chat, Anna says they did a table, and Shrist jumped straight here by saying the A statement is a logical contradiction. Maybe you've heard the statement before, I guess. The statement "I am currently lying" is very suspicious. It's not possible if I always tell the truth, and it's not possible if I always lie, because always lying is actually quite restrictive. Yeah, always lying. I've had some puzzles with sort of guards and people. You have to ask them questions, and always lying is a real burden. Right. Let's pause a moment to think about the plight of B before moving on to part 2. I do love these. You know, you've got these bits and pieces to think about, and sometimes they introduce new stuff like this contrarian, which we're going to have to think about quite carefully. They tell a lie if they're the first to speak, or there's loads of stuff. We get these statements. So I suppose it's quite tempting. Oh, look, QRP. They're kind of statements in order. Very nice. Each person is pointing at somebody else, being the liar. So I suppose sometimes you can do these case-based. Let's try and do this one with a different method, different style. Anybody watching think they've got a different style? Different style of how to approach this? I don't mean like a different personal style. Also, it's been about an hour. If you've been looking at the screen for the last hour, then remember to blink and look away from the screen. If you've been watching this on your phone for an hour, remember to put your phone down somewhere, rest your arms. I'm going to drink some water. I'm also going to mute myself. Think about lying for 30 seconds. Letters are more confusing than names is the opinion in chat. I think I agree. I just find it more fun if you can point at one and say, Charlie, up to no good. Charlie. In this case, Charlie was up to good. Charlie was the saint, which I feel like is redemption. I think there's a different past paper question where one of them, possibly Charlie, broke a vase. They were kind of the same names each year for a while. Right, okay, PQ and R. I haven't seen. Yeah, so we thought we had a style here of thinking about the kind of core question being what's A's role? Maybe if you've done a table that's like, I don't know, the rows and columns of your table, rows or columns of your table. A different question you could ask is A's statement true or false or indeterminate or something? So you could look at statement by statement and think about the cases for the statements. Sometimes you get to do a more kind of all at once approach, which I'm going to try and attempt for part 2. It's sometimes faster, sometimes harder to think about. I haven't tested this, let's find out. Someone in chat says, never thought I'd see James doing a computing question, so here we are. Let's find out why not. We've got a liar, a saint, and a contrarian, and I've noticed that these 3 statements are very similar. Each one is saying that someone is the liar. So I know that out of these 3, actually there's only one liar. So one is true, and the other 2 are false. So what does that tell me? Okay, the saint tells the truth. The saint is telling the truth, that's fine. The liar is lying. That's okay. That's okay. Oh, so therefore, so putting that together or something. Scribbled notes, not very good. So putting that together, oh, the contrarian is telling a lie. So now I can think about why the contrarian might be telling a lie. Now I hit some cases, I think, because there's an or right here. The contrarian tells a lie if they're the first to speak. So it could be contrarian, and then in some order, liar, and saint, or if the preceding speaker told the truth. So the contrarian could be right after the saint. So I've ended up with some cases anyway, so I'm slightly disappointed. Probably I'm going to have to look at what the statements actually are. So this kind of holistic approach where I try and talk about all three statements, it gave me a true fact, but it's kind of reductive, because putting all three of them together, I'm no longer thinking about who said what. Okay. Right, do I want to follow up those cases, or do I want to try and do cases a bit more like yours? How about we do both? Let's do both. Yeah. You tell me in chat how your cases work, and I'm going to pursue this slightly weird way of doing the question, just to see if I can make it work. So it might be first, so they might go contrarian, and then, oh god, and then saint, and then liar. Or they might go contrarian, liar, saint. And they might go, or they might go after the truth teller. There's a word for that. Truth teller is actually the word saint. Anyway, so the sequence of roles might be saint, contrarian, liar, or liar, saint, contrarian. No, yes. So I've got four possibilities. Four possibilities for what the sequence might be, and now I need to go back and read the actual statements. In particular, I'm going to look at the saint and the liar, because the contrarian looks very confusing to me. I suppose they're lying. Yeah, okay, they're lying in all cases, I already know that. So the saint would be, okay, so in this case, the saint would be the middle person. They're saying R is the liar, which is correct. But the contrarian is, yeah, the contrarian is lying, Q is not the liar. So that one's fine, I think. In this case, do I need to look at another case? I probably should, shouldn't I? In this case, the last statement would be true, P's the liar, but that's inconsistent with my schedule, where I think the first person is actually contrarian. In this case, I've got the saint up top. They say Q is the liar, but that's not consistent with my kind of schedule of what I've got. And then this last case, I've got a saint in the middle. They say R is the liar, but that's not consistent with my kind of role assignments. Okay, so that actually wasn't too painful. I had 4 possible role assignments out of 6. Oh no. 4 possible role assignments out of 6. And then I checked them all. What did you tell me in chat? You told me about references and interviews, and there's lots of reasons that we might look at the rest of someone's application as well. It's not all about that. It's that question still. References, your reference is probably going to tell us about how much you like maths and how what you're going to do at university. It might contain some important other information as well. Sometimes people's reference is really important because it tells us something that we need to know about, for example, why their particular grade isn't what we would want to see, or why they don't have a qualification we might expect. The teacher's reference or UCAS reference, or generally UCAS reference, might have that sort of information in it. Can it still be LCS? LCS. I think if the contrarian goes after the liar, they would be telling the truth. And then we'd have 2 truth tellers, but their statements are not consistent with each other. 2 truth tellers should agree about who the liar is. So I think we can't have LCS. The other one I seem to have ruled out is SLC, the Saint Liar Contrarian, because then the contrarian would be going after the liar. I'm a bit disappointed, really. I was quite, I think if it had been the other way around, then I might have been able to eliminate 4 of the 6 cases and only have to look at 2 cases. But I did all this kind of clever adding the statements together, and I only got down from 6 possible role assignments to 2. I'm talking about these role assignments as, what sequence are the Saint, Liar and Contrarian in? How do I know the contrarian is lying? Ah, yes, this is my key, not excellent deduction, but I think the only interesting thing I've done in this question is to say, here are three statements that they've made. Interestingly, they're all different and they're all inconsistent. That means that exactly one of these is true. At the end of the day, one of these three people that they're talking about, between them, they're talking about everyone between them. Between them, exactly one of these people is a liar. And so the other two statements are false. So we know that three people have walked into a room and then proceeded to tell two lies, one truth. We know how the liar and saint are behaving, that one of each, but we've got this leftover case where we've got one extra lie to account for. That's the contrarian. They're doing some lying. And then sadly for this argument, the argument then goes on and on and on, because there are loads of reasons why the contrarian might be lying. They do that just if they're the first to speak. They just love lying. Live life lie. Sorry, I think I might be coming out with this kind of like really enthusiastic pro-lying standard, which not the best thing to go for, is it? Yeah, the contrarian can't tell a lie directly after the liar. They want to be different. Sadly for my scheme, they don't speak after the liar very often. Who writes references? Anyone can write reference except family members and friends. The rule is just that they should be someone who can comment on your academic achievements and predict you any grades for outstanding qualifications that you haven't yet completed. They don't have to be a teacher. They usually are for most applicants, but they don't have to be. Is top down first last said? Yeah, I think so. I think top down is the order. I agree that could be slightly clearer. Hey, Apples has just checked in. That's a second Oxford student in chat. Beth is busy quoting, doing the quotes. Right. Struggling to do paper in timed conditions, advice on speed up. I think it's going to be some sort of mix of fluency on kind of familiar things, just get those out of the way quickly. If you get it down to some sort of quadratic equation, spoilers, this one is not going to turn into a quadratic equation, but if a question did turn into a quadratic, I like to think that I'd be on that quickly. I'm quite rusty. You're faster than me at quadratics. That sort of thing is good. I think there's also something to be said for just sort of getting started. Just start writing stuff on your rough work, just to start having a go at things. I know people might like to try and sort of read ahead and find out what the rest of the question is going to be about, but I like to just sort of start mucking around. So here, oh my goodness, there's this 5 statements. There's only 3 people. Why are they doing so much chatting? I've learnt my lesson now. You've got these first 3 statements, but I'm not gonna do anything. Also, because we don't have a saint anymore, so this is pretty bad. I like this, but I think it might be quite boring to watch me do this. I think I might let chat talk about this. And there's another question about reducing the number of silly mistakes when doing a paper. I think, don't ask me, I make silly mistakes all the time. I suppose we spot silly mistakes by reading what we're doing, or looking, not even looking back at your work, but just looking at what you're doing. To always have a slightly critical voice that says, I'm writing out lists of letters over here. It's one of each, right? Yeah, it's one of each. What are the things? I'm glancing back up again to see that it's CSL as the 3 cases, and trying to check that I haven't written the same thing twice. And I'm trying to think about all these kind of mistakes I've made before that I'm trying to avoid all the time, which I guess is just experience, right? To say, yeah, I've previously made a mistake where I would write down something like this, right? Where I don't spot the. I'm so excited by the CS combination at the start and the idea of writing down all the possibilities that I also include CSC or something. Say some sort of grounding to keep checking back against something that you've got. Okay, in chat at the top there, Arlen says that just that X is the liar, which I mean that'd be consistent with the first statement. Y is not the liar. I guess you've probably also got opinions about Y and Z. And Y and Z. It's interesting that Y says this straight after X says this straight after Z. That's an interesting structure to me. Although maybe I'm just reading too much, and maybe I should just start doing cases, right? There's only 6, so would this conversation make sense? Liar, switcher. S is now switcher of the saint, but now it's switcher. Good thing we haven't got a saint and a switcher in the same question, otherwise my notation would break. There's only really, I guess my C's and L's look the same. There's a mistake coming. There's only really 6 cases to check. And checking one of those is fun. Maybe not on a stream, but fun to try. So for example, SCL would be switch. So this would be a switcher statement, so I can't, that's fine. This is something a switcher might say. Do they switch backwards and forwards? Scroll back up. Sometimes, it's just sometimes. It's a little sometimes thing. Okay, so this will also be consistent with the thing a switcher might say. Maybe this is your table, maybe this is your column of your table or something. There's no truthful person in this question. There is a liar, there is a random sort of person who sometimes tells truth and lies, and a contrarian who behaves in this mad way where if they go first they lie, otherwise they do whatever the previous person wasn't doing. Which is tricky. It means they have to evaluate previous statements to work out if the previous statement was a truth or a lie. I suppose they have this kind of other case. What does the contrarian do if the switcher says something totally nonsensical? It's kind of neither a truth nor a lie. Is that the case for A? I've got distracted. I'm just going to think about this for a second. If A says, I am the liar. Oh, sorry, yes, that's just false, isn't it? We don't have some weird neither true nor false kind of thing going on. That's just false. It's just not the kind of false thing that... it's not the kind of false thing a liar would say, because that would be true. It's only contradictory, not nonsensical. Gosh. Right, well that was fun. I thought I could create a situation where I really mess with the contrarian, right? I'm still not sure that you can't come up with such a situation where they walk into the room, the contrarian is all ready to lie because they love lying, and then the switcher goes first and says something mad, and the contrarian thinks, well, how do I do the opposite of that, right? What's the opposite of insane? I could tell the truth, I guess. But, yeah. Yeah, the S's have confused me as well. They were briefly saints in part 2, and I think they're now switches. Shall I find out which thing isn't consistent for this case? Switcher, contrarian, liar. So we'd have the switcher bit saying that Y is a liar, which is false. Yes, tick, that is false. Y is not a liar in my scenario, Y is a contrarian in this thing I'm imagining. So I've just seen someone lie, so then they must tell the truth. So that's okay, that's true, they're trying to do the opposite. And then Z, who I have down as a liar, says that X is a liar. That's fine as well. I'm getting worried because then X says Y is a liar. I still think they're a switcher, and I still think this is false. But then Y, who I have down as a contrarian, says that X is the liar, which is false. And that's not how contrarians behave. Gosh, that was hard to follow. It was all going so well until Y kind of changed what they were saying. Whereas, okay, so Y changed what they were saying. Maybe I could have spotted this, right? This will eliminate another case, so this is worth saying. Y changed their tune. They were in the same situation, following the same person, making the same statement, but their behavior was not dictated by that previous thing, or by, the truth. Maybe it's dictated by the truth. Maybe neither of those people. Oh gosh. Maybe it's dictated by the truth. Okay, Y is not the contrarian. Great fun. I'm I'm having a great time. What counts as a friend? That is an excellent question, to which I don't really know the answer. There is a little bit of guidance on the UCAS website. It's kind of a UCAS question because we're talking about UCAS references there, to think about who can be your UCAS reference. If in doubt, I would not pick someone who's a friend at all, really. Maybe you're just asking because you're quite good, you're quite friendly with your tutor or teacher or someone. Anna asks about, Anna asks about if the contrarian lies after a lying switcher. I think they tell the truth after a lying switcher. Yeah, because we're not in either of these cases. They're not going first, and the preceding speaker did not tell the truth. So in some other case, where the previous speaker was a lying switcher, they did not tell the truth. So I think the contrarian would now tell the truth. I think you can run into trouble with this. Part of me wants to spend the next half an hour designing a especially weird statement for a switcher to make. It's going to be really fun. It'll be something like, the next person to speak is not going to tell the truth, or something fun, right? Because the switcher, you can get into real trouble with this. If the switcher tries to kind of anti-guess what the contrarian's about to do, then they can really mess with things. Yeah, this would be good, wouldn't it? You could probably roleplay this. This probably makes much more sense if you are 3 people. If you are 3 people, then you can be one of them each. And it's much easier to focus on being one of these people. Part of the tricky thing of this is perhaps that you have to imagine being all 3 people. You have to be the switcher, right? And switch between all of these cases. And that involves a lot of kind of switching between who you're imagining being. If I were this person and I said this, would that be truthful? Is that what I would do? Separate questions. That's quite hard. Whereas yes, if you are 3 people, yeah, I'm lost as well. I'm trying to move on, I think. I brought in a truth lie question. I don't regret it. It just hasn't made it. I haven't given you the impression that I could do this question. Just making a lot of point. Yeah, so for the new multiple choice questions, the question will say how many questions it's worth. We have on the Pearson View system sort of demonstration of that. If you want to see a question with square bracket, 3 marks, close square bracket written next to it. Okay, what are we doing next? We've got about half an hour. We've had a look at 3.5-ish questions, looking at bits where you might explain your working out, especially. We could do some quick fire multiple choice questions. We could do some weird quick fire questions. Should we do that? I'll just put some on screen while you're thinking about what you want. For example, what about this? This question would like to know which of these graphs. It's multiple choice, but with graphs. Isn't that fun? There's different things going on here. There's a 2 to the minus x. There's a sine squared of x squared. I believe that this question is in radians. Just as a warning, it's from back in the days where questions were in radians. I don't know how I would do that in degrees. I would probably just relabel stuff and hope it worked out. You're going to go for 2 minutes per question. It's up to you. There are 25 of them, so that would take you about 50 minutes. Then you would have quite a long time for you're going to 2 minutes per question. Just think about timings. This person at the top there, they're anonymous. They're going to try and do a multiple choice question every 2 minutes. So they'll get through the 25 questions in 50 minutes, and then still have an hour and 40 for the long questions. Sounds speedy. Look. Right, okay. Yeah, let's try putting in x equals 0. Good strategy, I like it. Most of the graphs agree that we should get 0, and in fact we do, because sine of 0 is 0. I wonder if this one might be something to do with cos. No, it's not even, is it? Not even that function, because was going to say because it's 1, but it's 0.5, so I don't know what's going on here. 2 to the minus 0? That's the number 1. Anyway, you plug in 0, which is a good thing to try. You get not this. So then you've got a few more of these, and at some point it's worth looking at the pictures to try and decide what the differences between these things. At some point you might notice that yeah, B goes negative. So I'm not keen on these negative parts because 2 to the minus x, I know that's positive. Sine squared, I know that's positive, so I'm not keen on those. So now we've got kind of this split between these two. Both of them have got this kind of decaying shape where they're peaks and troughs. The peaks are going lower and lower. In this case, I would say they look quite well. Are they equal spaced or kind of shorter over here actually? So it's hitting 0 more often, whereas in this case, it looks like maybe they're equally spaced. It could be equally spaced. Hard to say. So yeah, maybe it's A just because we've got this x squared inside sine squared. And maybe the intuition here is just sine squared of x squared is going to be weird, right? It's probably not the same picture as sine of x. It's going to be weird, hasn't it? Putting x squared inside, that says something like, as the number gets large, it should, well, x squared increases faster and faster. So if you imagine the angle around a circle as being the thing that you put into sine as an angle, in degrees or in radians or whatever, then as you go round and round, x squared gets larger faster and faster. So it's like going round and round faster and faster. I started fast there, let me start slow, then go fast. So up and down, faster and faster, which looks more like A, I think, sort of faster and faster. At some point I've messed around with Desmos and I've put different functions inside different functions. So I guess I've built some intuition about if the function inside goes faster and faster, then you see kind of a squashing effect. I guess you know that sort of thing from scaling graphs. You might like to try grabbing desmos.conf and putting functions inside other functions just to see what happens. Worst case scenario, it breaks Desmos. Yeah, it's going to be A, isn't it? Yeah, sine 1 over x is good fun. Good. Right, okay, there's a request. Let's have a look at this requested question. A good graph sketch there. I like showing people that we can do graph questions as multiple choice questions. So if graphs are your favourite, then don't worry, we can do those in multiple choice form. There's a request over here for this sort of thing. Oh, look at this. I say this sort of thing is a request for this, isn't it? That's 2009 question 1J. It's pretty tough. It's not asking us to solve this equation so much as asking us to count the solutions to this equation, but again, in order to count them, it's probably a good idea to think about what they are. That doesn't always work. You might end up just thinking about where they are, or roughly what they are, or what the relationship between them is, rather than literally trying to list all of them, because, well, there might be a lot. There might be none, or there might be a lot. Some of those options are huge. Powers of 2, which maybe makes you think about powers, which maybe makes you think about multiplying things out. So I suppose I can see about 2 to the 30, and I can see 2 to the 10 as one of the options. So that's quite tempting. I can see powers of 3 in here, and well, here's a concept that generalizes quite nicely. If you have something like this, which is not quite a polynomial, like you've seen them because it's got 2 variables in, it's got x's and y's. So if you have one of these, where you have different terms with powers of x and powers of y multiplied together, and then all of those things are added together, so a polynomial in 2 variables, some people might call that. Something you might try, just to make it look more familiar like a polynomial, is to think about y equals x. this doesn't really help you with the question because, well, some of these pairs might have y equals x and some of them might not. So it's kind of daft to say think about y equals x because that's only going to be some of the cases. This is a bit like thinking about, think about x equals 0, think about y equals 0. It's a kind of trick along those lines. In this case, if you think about y equals x, then all of these terms are like x cubed. And now I'm really thinking about cubes. And it is time to recognise that this thing is a cube on the left. Because 8 is also a cube number. It's hiding in there, but it can't hide. That's 2y cubed. So now I'm really thinking about how maybe this is some sort of cube expression. I'm doing this kind of working out because I think the web solution just says recognise that this is x plus 2y all cubed. And it's quite hard to see where that comes from. People in the chat are telling me this as well. Yeah, sorry. There you go. Telling me about binomial expansions and powers of this, but I think it's quite hard to explain how you might think of that, or how you might notice that this question's all about cubes. The word cube doesn't appear in the question. It's all about cubes. So when you're looking at the question, at what point do you start thinking about powers of 3? And it can't be as soon as you see x cubed. Your personal rule cannot be as soon as I see x cubed, I think about everything is a cube. You've got to read more than that. So maybe it's the context of seeing that all of these things behave a bit like x cubed. Maybe it's the presence of a 3 over here, which is a bit less obvious, but whatever. At some point you notice that yes, this is 3 choose 1 times x times 2y, and that this one over here is 3 choose 2 times x times 2y squared. Sorry, these are x's. I realised I was saying times out loud and writing an x. Problem. Yeah, so we have on the left hand side exactly what we would get if we multiplied out x plus 2y all cubed, blam, to the power of 3 here. We'd get these 4 terms. So it's kind of asking you the opposite of something you might be asked at A level or equivalent, because A level or equivalent might ask you to multiply out that cube and make sure you get all these coefficients just right. Whereas here, the trick really is to recognise that that's what's happened. Somebody else has done this. Recognising that, I suppose, is more easy if you've personally at some point in your life multiplied out x plus y cubed or something. So, homework task, if you want practice spotting this sort of stuff, is to just do anything. Just multiply stuff out. Put horrible sines and cosines in, or whatever you like, and see what happens if you multiply things out. Because that's just experience. That'll help you recognise stuff faster. Anyway, for this question, something like 2 to the 10 cubed on the right hand side. So we're making progress if we just write down x plus 2y is equal to 2 to the 10. Excuse me, that equal sign came out like a not equal sign. What a horrible typo. Okay, there's some solutions to this. I mean, 2y is even. It's somewhere between positive integers, somewhere between 2 and 2 to the 10. So, how many even numbers are there really between 2 and 2 to the 10? Answer about 2 to the 9 of them. Probably C. Anyway, rough thinking out loud. Let's try and do this. So once you've spotted a cube, you can cube root both sides, which makes the equation much nicer. If the question was printed like this, if it just said the number of pairs of positive integers xy which solve the equation, and then it said x plus 2y equals 2 to the 10 is options, well, then we're talking, right? Because you might think, well, 2 to the 10 looks plausible, right? X could be anything between 1 and 2 to the 10, but then you realize, it's got to be y's got to be an integer, like a whole number. So 2y is going to be a whole number, an even whole number. That's a bit more restrictive. If I handle the case of 2y being even, then x can take the kind of leftover stuff. X will be, and x is fine, x is just 2 to the 10 minus 2y. So we should check that this is positive as well. So this is even and positive, and we should check that this is positive. That gives me some inequalities for y. The 2y is some even number between, well, it's larger than 0 and strictly less than 2 to the 10. It starts to feel like 2 to the 9. There's a -1 in there because these are strict inequalities and counting is hard. Yes. Yeah, if you see a weird expression, you might like to try a binomial expansion. I think there's another past question. We might get to it at some point soon, so spoilers for the future. But there's a kind of curve sketching question I've seen where there's an expression. There's an expression in the question, and you're asked which of the graphs is a sketch of that, and it is absolutely mad because the expression is huge. And then you spot that someone has taken a nice simple expression and raised both sides to the power of, I don't know, some large number, like 3 or 4. And once you spot that that's what they've done, then you can kind of undo that step and then start working with the simpler equation. It's almost like a layer of disguise. But this question is really about this equation down here. Whoops, missed. Really about this equation down here. But there's a kind of level of disguise that both sides have been cubed, which you have to spot. So it's kind of testing your familiarity with binomial expansion of multiplying out these cubes, but then also doing a fairly sort of counting kind of question at the end. I agree. I think they can't be 0. I think positive means greater than 0. Is this one of those things that people have mixed opinions on? No. Some people think that 0 is neither positive or negative. I think I agree with them. What's the other opinion? Maybe some people think 0 is positive. I guess that's the question in chat. Maybe some people think 0 is positive. Non-negative is a word that people sometimes use. Related concept. I've lost track of what we're doing. We've done a hard multiple choice question. Where are we jumping next? 20 minutes on the clock. Anything you want to talk about? If not, I'll put another question on the screen. Bad news. You get questions either way. You can choose them, or you can let me choose. Do I want to see this? We've done a question a bit like this, I think, didn't we? In the trigonometry session, maybe in revision, thinking about equations like this sort of thing. I might have had a cos squared, and yeah, I definitely remember showing you some sort of grid like this. I enjoy this one because the past paper question is all multicoloured. I think it was printed in black and white, but behind the scenes it's all multicoloured. Not that, yeah, you know, that's not useful. Can we do it, please? I'm not sure. Oh yeah, wait, hang on, you're the same person. But I put those messages in the wrong answer. What was the answer C to that one? Yes, I think it was. C with the 2 to the 9 minus 1. I think it was C. This one, now on screen, could be anything. Yeah, Tim wants to think about periodicity, which is the property that sine x has, that you can, well, what can you do? You can add 360 degrees, or 2 pi radians for people who are using radians. I think these ones are in radians again. If that's annoying you, by the way, this idea that past questions were written entirely in radians and you haven't learned about radians yet, at some point I went through all of the past papers and made notes on which questions in particular use radians. So not spoilers, but which questions are using old things that used to be in questions like radians and the trapezium rule. I guess you can usually tell which questions are about the trapezium rule because the question says it's about the trapezium rule, and you think, wow, this is a really old question about the trapezium rule. We don't have that on the syllabus anymore. Those notes that I wrote up are in the table of past papers. It's probably where you got your past papers from. I don't know. Depends a little bit where you get your past papers from. But on the MAT page, which I'm going to link people to, not the live stream page, but the kind of main MAT page with resources, there's some little notes about just things like this question used the trapezium rule, which is no longer on the syllabus. Is this C as well? I think it could be, couldn't it? I kind of want to plug in 0. 0 is quite powerful, isn't it? You put in 0, both sides are 0. So, oh, 0. And actually that immediately eliminates B and D. So that was quite a clever thing to try, if I say so myself. 0, eh? This is one of the reasons that we went up to 5 options on multiple choice. You know, you got 5 options on multiple choice because we just eliminated 2 of them with only having 1 idea. So now we've got to kind of 50-50 guess, which could be described as thinking about, well, these pictures just differ on the line x equals 0. So I could probably get away with this question just thinking about, or even on the x-axis. I could probably get through this question just thinking about y equals 0 only. On y equals 0, you're asked which points satisfy sine x equals 0. And those are pretty predictable, aren't they? Whereas sine x 0, 0, then again at 180, and then again at 360. This question's in radians, so imagine that I said 0, pi, and 2 pi. So it should be 0, somewhere around pi, somewhere around 2 pi. Look, radians. Yeah, the grid makes more sense for a symmetry reason, doesn't it? Yeah. 180 minus y is also possible. Good reasoning. I like that. You remember the other thing that sine does. So sine has a couple of rules, doesn't it? Sine of, well, loads of rules. What am I talking about? Should try and be truthful, shouldn't I? No, I always lie. That was a joke. It has rules like this, which I'm just writing up there that people have noticed. Oh look, Beth, you managed to get the radians greater than degrees thing to catch on. People are going to have to head back in time to find out when that was from. Beth make that happen? Just checking. Yeah, it was Beth, wasn't it? Right, okay. Big fan of your work. Right. There was a request for questions from 2009, and I'm going to try and accelerate a little bit. I'm also going to turn this light on because it is getting dark. Ugh, horrible. There you go. Yes, you've also worked out how to highlight your own messages. Good use of power. That is horrible, isn't it? Can we get that a bit less orange? That's best I can do. Right. I've fallen off the bottom of the world. I was trying to find 2009. There was a request for E and for I. Ah, yes, this is good. This question's in radians, which some people are big fans of. This question's in radians, and it's got 4 options. It is candidate for the most 2009 question of all of 2009. Here it is. 2 to the sine squared, 2 to the cos squared. Probably whenever I see 2 to the sine squared and cos squared, I like to think about this as, you know, maybe I'm a bit predictable, but I like to do something like this, right? It feels right. There's a flashcard for that. If you download the flashcards from the live website, you can have one of the flashcards says sine squared on one side and cos squared on the other side. To help you remember that those things kind of go together. Kind of want to just solve this. Is there a faster way of doing this? I think I've seen this question before, and I remember there being a fast way, but I do not remember what the fast way was. So I am going to try and solve the boring way, which involves making a substitution, because I've got this horrible 2 to the sine squared thing appearing twice, with a minus sign up here in the exponents. That's a 1 over sort of thing, using lots of different bits of the syllabus at once. I think this has got no solutions though, because completing the square, this is rubbish. Suspicious. How do I feel about this? I feel like I've speeded past something obvious. Yeah. No? Can they both be 1? 1 plus 1 is 2. I've been warned about 1 plus 1 being 2. But that happens if both of those things upstairs are 0 and they're not 0 at the same time. In fact, is there a rule like... It just looks quite implausible, doesn't it? Because I know that sine squared plus cos squared is 1. And powers don't work like that. No, you can't add powers together like that. Is the answer. People seem to think this holds for all values of x. Or maybe not. The discriminating go away. Well, I still completed the square, but I think I might have done it wrong. Because this question has completely fallen over for me. I sort of do want to do it with powers actually, with some mad inequality to explain how, because sine squared plus cos squared is 1, that makes it more unlikely. that when you apply a function to these things that they stay equal. I think I might be wrong though. Good chance I'm wrong. Someone in chat thinks it's A. Yeah, multiple people in chat are telling me everything cancels and it holds for all values of x. But I think you're doing something quite funny with those powers of 2, right? If I show you like 2 to the 3 and 2 to the 4, you don't get to add those. That's not 2 to the 7. So it's true that sine squared plus cos squared is 1, but you don't get to add powers like that. It's not how powers. I know that sine squared can't be 3 and cos squared can't actually be 4, but yeah. I'm going to quickly check because I'm nervous now. It's almost 7 o'clock. This is prime time for me making stupid mistakes. Let's find out what stupid mistake I've made, if any. Where am I? Yeah, there are no that. Yeah, there are no solutions. Huh. The web solution is different. Annoyingly, that does happen sometimes. The web solution points out that both of these expressions on the left are larger than 1 or equal to 1. And 1 plus 1 is 2. So even if these things take their minimum values, you get exactly 2. But they can't both be 0 upstairs at the same time. Okay, I think I prefer my quadratic stuff because it's the sort of stuff that I do on lots of questions like this involving sine squared and cos squared. Instead of trying to turn it into a question just about sine or just about cos, maybe make some sort of substitution for whatever function I've got left over, and then do quadratic science to it. You see an equation like this and you think, this is going to fall apart now, because when you see an equation like this, you maybe think, I can turn that into a quadratic, and then I know loads of things about solving quadratics, like discriminants and completing the square or whatever. Or failing that, maybe you mess around with this equation a little bit, and then you see this, and then you think, aha, that is a quadratic. I know what to do with quadratics. I can write down the discriminant, or the quadratic formula, or complete the square. And I went for completing the square, because, well, when I see u squared minus 2u, I've seen that before, so I don't mind completing the square if it's a very familiar square. Yeah, Shrot in chat says for it to add to 2 would need to be 2 to the 0 plus 2 to the 0. Side note, because anything has to be larger. Yeah, and sine squared x can't be 0 at the same time as cos squared. Good. Good, yeah, okay, like it. There was a request for J, but I think we already did 2009 J. Right, Anonymous says, isn't the way you've done it, James, correct? Yes. Everyone in chat, more or less, made me doubt myself. But the way I've done it, I think, is correct. This is, I said it wouldn't happen, but here it is. A question that's turned into a quadratic expression. And then we got to do quadratic science to it. We haven't done a minus sign error yet. Worst minus sign error of your life so far. That's me talking to myself, but with a Simpsons quote. Yeah, Tim says the other way is quicker. And I think I agree, but you do have to allow time for spotting it. There was a request for another thing. I've forgotten what it was, so I'm just going to scroll back through chat. Exponent properties, but not the adding one, because that's not one of them. What was it on? 2009J. We did 2009J. We did it. We've come round. Oh, maybe they've requested them in this order. I'm confused. Look, here's a question about the trapezium rule. It's really obviously about the trapezium rule, though. Just to be really clear, trapezium rule, not on the syllabus anymore. We can't ask this question in 2024, I guess, unless we explain what the trapezium rule is, and then that would take ages. Anyway, maybe you know the trapezium rule anyway, which would be nice, because that would let you do integration. Right, I had this one highlighted as a kind of nice question to point at. I think we've talked about questions like this. It's got this kind of recursion thing going on where each term depends on the previous ones. They give you some initial values and then do this. This question is nice because it even helps you calculate the next term. twice the previous minus the one before that, but then add 1. What a weird rule. I tell you, look, the structure of the question here is telling you to do the next couple of values, which is a healthy thing to do anyway, but here you actually get marks for it. So it's a nice thing to do anyway. Right, for this kind of ABC thing, which I've seen in a different context, I think we talked about a function at some point with A's and B's and C's in it. They're asking you to compare this expression, for which A, B, and C are fixed constant numbers, but n changes, right? Because xn says for different values of n, you get different things. I want to zoom in slightly. I might hide chat just for this last bit. So just to be clear, this is talking about how xn might be equal to some sort of explicit statement for what the value is. None of this recursion stuff. Some explicit statement in terms of n. Oh, and in terms of 3 numbers, which are currently mysteries. We don't know what these real constants A, B, and C are, but hopefully we're going to work them out. That's the question. And a good way to work them out is to say, well, if this fantastic formula really works, and then this should work for 1, 2, and 3, each of them. That's 3 separate claims that when I put 1 into my magic formula, I should get exactly the right number. I kind of do, right? I get A plus B plus C, and it's mysterious. It might be the correct number. That's supposed to be 1, because just off the top of the screen for me, it's the information that x1 is supposed to be 1. And if you plug in 2 into the magic formula, we don't know where this has come from. I'm calling it magic because where did that come from? You see this? You don't really think quadratic formula, do you? Straight away. Never mind. That's supposed to be 3, and then the next one down is supposed to be 6. Oh, they gave me all the ones I needed. 1, 3, 6. That's the system of equations. You can solve those. We're pretty good at solving those, I think. Do some sort of subtraction of the equations or something. Good. What was this question? Question 3, part 5. That's a different part of the question. Can we just compare the coefficient of n? Yeah, I think I've seen that question before. I think you compare the coefficient of n, but you also must check. Coefficient of n tells you something about the different question. Tells you something about the large term behavior. What's going on for very large n? Really depends on the coefficient of n. Yeah, down here somewhere. You need to also check what's going on when n is 1. This is supposed to be true. There's some statement, the context here is there's some statement that's true for all values of n, including large values of n, which sounds like a stupid thing to say. When you read this inequality, you don't normally read it as all values of n, including large values of n, but a person in chat has got part of the argument where thinking about very large values of n gives you this kind of, like this thing, 3n squared, and this thing over here is like 4an squared or something. So it tells you something about a, you sort of think, interesting. Some coefficient stuff going on here. For the smallest possible value of b, you maybe want to think about the coefficient of n, which will tell you about the behavior when n is very large, but you want this to be true for all n, including the small n as well. So you need to think about those two. Good. Chat quickly. Blam. There it is. This question goes on to do other stuff, but I just wanted to highlight this part again. We've seen a structure a bit like this during the revision sessions where they kind of give you a formula, but you have to do some work. And that's confusing because I suppose part of it is given to you, and part of it it's up to you. You get a helping hand. I'm highlighting it because that's how you get through quite hard questions, maybe, is by being given a helping hand. Maybe on the mat, especially in interview. If you're interviewed for maths, then you might expect to, during the interview, achieve something really difficult, probably with some sort of help along the way, or some sort of prompting, or being taught something new. All of those things involve something really tricky that we need to do together. And that's something that I try to do in interviews sometimes. Sorry, somebody asked about interviews a while ago. Can we just use arcsine of sine x? I'm not even sure which question you're asking about. Oh, is that the sine x equals sine y one? Yeah, sure. If you know about arcsine, and you can tell me about properties of arcsine, go for it. Yeah, so Tim's got a point that long questions are focusing on explaining, because we still want to do a bit of that. See your explanations and justifications. Good. Timeline to prepare with 2 months left. Well, we're doing some past papers at the moment. You might identify along the way there are particular topics that you want to revise. You might spot particular things that you want to do for your own preparation. But I sort of hope that at least doing past paper questions is helpful for you revising A-level maths anyway, as we're about to go into September and school starts again. Hopefully this kind of mental gymnastics of trying weird questions is hopefully helpful to you either way. Good, right, okay. That was supposed to sound like a wrap up because we've hit 7 o'clock. I don't know what that is. I think my spacing's wrong. Somebody's tried to put ASCII art in chat and it has only sort of worked. They might have counted the width. Let's approve it and see what happens. Have they counted? Sort of. That's almost perfect. I'll take it. Good, right. There are 2 long questions this year. For format questions, please see Matt webpage because I have to stop being live now. But luckily, there are other sources of not live information. You can find out more about the live stream at website/r/matlive and the Matt in general at website/r/Matt. Good, right, okay. Take care, and I will see you same time next week for another episode of the Oxford MAT Livestream. Bye. It's been a while. Which button do I press? It's this one.